use our own terms, like, layman's terms versus Enlow's terms, so that things can start to make sense to you, okay? And I know who did and did not, so I'm going to try to help out here. Anna, can you tell me what enthalpy is, or enthalpy is? Okay, so your symbol is delta H, right? Give me a thumbs up. You know enthalpy. Enthalpy kind of relates to the thermal energy aspect of a system or of a reaction, and delta H is how we symbolize that. So you're telling me it's the heat of the reaction. That's kind of what you're saying, right? And the heat is actually related to two types of energy, PE and KE, which means what? Potential energy and kinetic energy. Okay, Jasmine, add to that.
Well, I was going to say, what is your triangle H?
Triangle H means delta, like a delta at the end of a floodplain or something, right? It's in a triangle shape. Well, it's a triangle, right? You guys know what I'm talking about? Like a delta at the end of a...
That
flows into
a body of water.
Yeah, delta. So it means, so triangle means delta, and we will refer to it as delta. Okay.
So that's just like a symbol.
Yeah. So enthalpy is the term. The symbol is delta H. Yep. Okay. Give me some options. Like, what are some varieties of enthalpy we can have, Savannah? Exothermic. Okay. So exothermic is one version. Exothermic, and delta H would have a what sign? A positive or negative, Savannah? Negative value, right? So exothermic is a negative delta H, and then Izzy? Endothermic is another way to express enthalpy about the type of reaction, and that's going to have a positive delta H. Good. Okay. So we actually have some reactions that consume or use energy, and we have reactions that release energy. Which of these versions, one or two, which one releases energy? Everybody, come on. Exothermic is going to release energy, right? Okay, so if I'm releasing energy and I'm writing energy in a full-on reaction, so let's like pretending A plus B, I'm going to write some word over here. So if I have a reaction that's like A plus B yields C plus D, and I'm showing that energy is being released, am I going to show energy here or here being released? In the products, right? So I'm going to say plus kJ, like kilojoules. Okay? So kJ is kilojoules, or joules in the case of just a simplistic way. So we're going to show energy released as a product. Okay? So then vice versa, what does an endothermic reaction do? Evan? Absorbs energy or consumes it, uses it up. So it's going to absorb energy. And we're going to write it as a reactant. There's really only one other way to write it. We're going to write it as a reactant. So if I show energy being produced, like here, this is a delta H of what? Negative or positive? Negative. Negative means exothermic. Or I can write energy being utilized, used, and I'm going to add it to the reactant side to show that it needs to be used and actually put into the reaction to get it to start. Okay? So which of these options, actually I'll get down to that in a second. Alright, so opposite, or not really opposite, the other style of a driving force reaction, Mackenzie, is what? Say again? So enthalpy was one force, or a driving force reaction. Entropy, right? So what's that symbolized by? Delta S, right? Entropy is delta S. And that's giving us a measurement of what, Zoe?
The disorder.
Good. So who has high disorder in their room, like at home? I got like a basket of laundry, some shoes. It's everywhere, guys. It's everywhere. Okay. Who has really low entropy in their room at home right now? Who's pretty neat and tidy? Okay. All right. So entropy is a measure of disorder. So what we see is that in a reaction, it's kind of hard to tell if something's ordered or disordered. The reaction itself doesn't help you out a lot. So instead we look deeper into the reaction at the what? States of matter, right? So pick up from there. States of matter. Matter, okay? So the states of matter matter. We definitely need to know about them. So tell me more about that. Maybe go.
So a solid is a orderly disorderly would be.
Okay, so solid, all the way to liquid, all the way to gas. So a solid is ordered, so it's pretty nice and in a constant kind of space and area, where a gas would be what? If that solid is ordered, then the gas is very disordered. And the liquid's kind of in the middle someplace. So which of these directions, going from solid to gas or gas to solid, which one is increasing disorder? Everybody. Right? So increasing disorder is going from the ordered state to the disordered state. So this is increasing delta S this way. So if we're going the opposite direction, you would say what? Decreasing delta S, or decreasing entropy, decreasing disorder. Okay, so what we now need to do is say, okay, well, there's two ways that reaction, or two driving forces of reaction, entropy and enthalpy. If both of the reactions, or both of the driving forces are in their favorable fashion, the reaction is going to happen 100% of the time spontaneously. What does spontaneous mean? Say again? Without help. Okay, so we're thinking about like to the notes side of things. Yeah, it's kind of randomly, just out of the blue, but it's without help. So it's just going to happen when you add the two reactants together. That reaction is going to happen like that. So my example, I don't know if I actually did this in the video, is if I have a cake and I mix the batter and the eggs and the oil and whatever, and I stir it up and I set it on the counter, is that reaction going to happen? No, right? So it's just not going to like bake itself, is it? So what do I have to do? I have to intervene and do what? Apply heat. I have to put it in the oven. So I'm forcing that reaction to happen because I'm making, as you probably will know, it's an endothermic process because I require heat to force it to occur, meaning I'm forcing it to bake itself. So endothermic processes are not really going to happen by themselves really frequently. We require an insertion of energy. So what are the two combinations, or the conditions that will help a reaction to happen spontaneously? Enthalpy must be one, either positive or negative, and entropy must be one, either positive or negative. Who can tell me which is the more favorable condition, endothermic or exothermic? All right, I heard a lot and proud. Exothermic. So I want that enthalpy to be negative. I favor an exothermic process because it stabilizes the reaction over time. Because if you're crazy and you're high on caffeine and high on sugar and you're just like pent up with energy, you're not really stable. So a reaction's the same way. We want to kind of bring it down to its chill state, like low energy state. So we do that by releasing this extra heat energy because it brings it down to a more stable state. Okay, so the exothermic is a favorable condition. So I saw a lot of you guys put happy faces. Thank you. That's how I think of it too. Okay. All right. So for disorder, this was kind of a weird way of thinking of it, but you're satisfying the universe. The rule for the universe is entropy or disorder always is increasing, increasing, increasing. So we must satisfy the universe. So do I want entropy to increase or decrease? Increase. So that's going to be a positive delta S. So does that mean things get more or less disordered? More disordered. And it's kind of weird to think of it like that, but actually compounds and chemicals are more stable when they're not so close to each other. They have lower potential energy. All right, so vice versa, if these are the two conditions that will happen to make a reaction occur spontaneously, what are the opposites of that would make a reaction never ever occur spontaneously? Entropy or enthalpy would be positive, meaning endo, and delta S would be. So is it a positive sign or a negative sign for making more ordered? Negative sign would be more ordered. Actually, I'm not going to call it more ordered. The definition of entropy is talking about disorder. Like we have to use that term. So it would be less disordered good. Okay, so these are two bad things. The reaction will never occur spontaneously if these both happen in conjunction with another. These are two good things, and so if these two conditions happen, the reaction will happen spontaneously with each other. If you have a kind of a combination of the two here, It depends on the temperature of the reaction, and that's a little bit above our pay grade right now, so we're gonna stick with these. Okay. So these are a set of questions that are on the bottom of your notes page. Okay. I want to review these pieces right now, and then we'll go for some more geometry. Okay. So there is a page that was on the. Can I borrow somebody's? Okay. So on the back of your mole map, way back, like last week, you guys had a set of equations that all related to the mix. So I wanted to give you guys that so you could take notes a little easier. All right, so I'm gonna do the first couple with you guys and make sure you're clear on how to interpret this. Who felt okay from the video, like grasping maybe 75% of what you needed to get? If you listened to it and you took your notes, now piecing it together, I'm trying to simplify it down to the nitty gritty right now. Okay. So first off, I need to determine the delta H and delta S for each of these reactions. And so, which conditions will make it a spontaneous reaction? Delta H will be what? Negative. Delta S will be positive, okay, which will make it non-spontaneous. Opposite, right? So delta H will be positive, delta S will be negative. All right. So if I'm looking at, oh, look, I see kilojoules, right? Automatically, I already know something. What do I know? So energy is being released. It's a product, so delta H is negative. So far, so good, right? Okay. Look at these compounds now. We have to look at their states of matter. We're going from gas to solid. So crazy disordered gases to a solid. Okay, so becoming less disordered. Okay, we got to talk about it in terms of disorder. So less disorder, what? Delta S is what? Negative. So frowny or happy? Not good. Okay, so is this one going to happen spontaneously? No. Okay. All right, so keep going. What do you know about enthalpy? For the next one.
The energy is absorbed.
Energy is absorbed, so delta H is positive. So I already know. No bueno, not going to happen. Let's go ahead and determine the disorder state, though. So we're going from gas to gas. Well, what did anybody pick up what I said to count here? Coefficients, which are moles of, not temperature, moles of the gases, right? How many moles of gas do I have on the reactant side? 1 plus 1 is, got it? Okay, so there's 2 moles of gas to start with, and I'm going to form only 1 mole of gas, right? So 1 mole of gas is more or less disordered than 2 moles of gas. Less disordered, right? Okay, so 2 crazy moles down to 1 crazy mole. So we got less disordered, so delta S would be, and we'd have a happy or frowny? Frowny, yes. Oh yeah, hold on, we have to balance this first. So it still works out though, because let me just get some space here. So H2, right, H2, and there's 2 here, and then there's a 2 here. Yeah?
Yes.
Okay, so it still works out because you still have 3. I did it because I knew we were going to go with this. I'm trying to simplify our stuff. So 2 and 1 and 2 is 3 moles of gas, and then we have forming 2 moles of gas. Same story though. You guys good? All right, so let's get on the lithium chloride one. Can you talk to me? Enthalpy? Good, so it's released, so this delta H is negative, yay. And then what do we know about the disorder? Increasing or decreasing disorder? Yeah, we're going from a nice solid, it's just chilling on the table, so some aqueous solutions are kind of liquidy and they're moving around. So this delta S is positive, so it's definitely yes going to happen. And this one's a no. All right, do the last 3. Go.
Alright, so
I don't have the extras.
I'm trying to understand. I went through that the last day.
Plus delta.
And then I. Oh, that's L, never mind. No, in the French, I thought it was like something else. Yeah, I thought it was something else. So it's going from a liquid to a gas, and it's gaining.
Okay, I already did that one.
So then, and why is the liquid next to it? So since this was So look, the 105 kilojoules, right? That's energy on the reactive side. I mean, on the produced side. So that would mean that it was energy released. It was released in the equation. So then we look back to the reactants, and you notice there's the liquid next to H2O2. Then the liquid's transferred to the liquid and the gas, so that in turn becomes more disordered. So it's going from a liquid state to a gas state.
Triangle.
Yes, I know. For the fourth one.
All right, back to me, and let's just take a stab at this. 3, 1 second. 2, eyes back up. 1. All right, I want to know yes, no, like whichever way it is for spontaneous or non-spontaneous. First one?
Spontaneous.
Yes, spontaneous.
No.
Non-spontaneous, spontaneous. So yes, no, yes. Why is this one no? Come on, Evan. Entropy is negative because why? Because it's going, can you tell me how you got that far? Like, that's the final answer. I want to know how you got there.
From 2 gases to 1 gas.
Right, 1 mole of gas plus 1 mole of gas is 2 moles of gases, 2 crazy moles of gas down to just 1 crazy mole of gas, more to order, meaning less disorder. So that knocks us out there. Yeah. So this hydrogen peroxide, I think you need, should work, 4, yeah, it's balanced. Okay. But regardless, we're making gases here. Making this gases means our disorder is increasing. So it's definitely going to be good. Okay. All right. So we'll chat some more with this at the end. And we're going to switch modes here. Okay. Pull up this paper for me. Call it Schmorgeometry. Schmorgeometry. Schmorgeometry.
Is that the joke for the day?
No, that's not a joke. It's a thing. It's legit. We're going to start with 1 at a time. You know? Makes sense. Right? Alright, so copy down this data table up on the board for me first, and then you're going to move to the back. That's second.
You just need to drop down the data table? That was
Well, so 2 things. 1, the pre-lab is that you have to write the correct BCE for making a s'more. There's only 1 correct BCE, Brown's chemical equation. And then I want you to figure out, when you're drawing your data table, you have these reagents or reactants. This is how much you have, and this is not really like what you have in the baggie. This is just saying that if you have this stuff, how many s'mores could I make based on these food items? Okay, so take a second, talk to the person next to you while I go turn the gas on.
What are you going to tell me? I'm hanging out with the girl right I'm just so proud of you. Yeah, like I've never been proud of someone. You're not right. You've come a long way from the summer. Oh, you're cuffed, living life. Yeah, I was worried about you. I was worried about you for No, I'm not.
It says 30. Where do you see that?
Jasmine.
Alright guys, I think this first part is pretty simple, but you have to have your rounds complete equation, so we're going to kind of do two things. You can ask me questions when you get back to the back. You have to choose to work with one person, claim them now. Give them that little like stare, wink, kind of smile, like you're mine, okay? Okay, and listen before we go back, okay? So when I say go, you can go. But you have to pay attention so we can have our assembly line pretty simple, okay? So the very, very back lab station has the very back lab station is my material side of things. So you'll start on this side of the lab station. I have a popsicle stick to roast our marshmallow on, I have some graham crackers, marshmallows, and chocolate. So you're only getting enough for one at a time, just so I know that I have enough for fourth period because I did put out like all my stuff for now, okay? So I do want to see your BCE in this filled out before you get that. After we get done with the s'mores, and there's some questions on there, it's a pretty easy lab grade. After you get done with the s'mores, you can ask me for help on the PS12, and then I have a crossword that you guys will be finishing, okay? So the crossword's right here on my desk, so you guys can get one with that, okay? Yeah.
Can we still work with that person?
Yeah, work with that person like the whole day, okay? You guys ready? Let's go. You do need goggles. I forgot to say that.
Is it okay for earbuds for time during course?
I was gonna text Darcy and I activated that for her.
Yeah, well, I'll probably, well, not all of us, but.
But some of you, come on.
Okay, cool.
Alright guys, clean the station. Okay, you're gonna have 6 people on stations. Scooch together. Scooch together. Listen, 3, 2, 1, listen. Okay, thank you. So everybody has flash flashes on, so we're going to turn the fire on. One person's going to get that Bunsen burner getting ready to go. I have the strike through the middle. The other person's going to come and grab the materials for just 2 s'mores. Okay, so one for you, one for your partner. Okay, let's go.
Isn't it half percent on the bottom?
Guys, 3 strikes and you're out. You not gas my room. Kenzie, read Okay, 3 strikes and you're out, guys. You guys can do
So all we gotta do is just do all of
Alright, guys, you need to start. You need to see some background before we get the other
I started
Turn it off. Turn it off. Turn it off. Thank you. Don't do that again.
It's hard now already. So you go. That's getting too big.
Alright, you're answering questions while you're decomposing. Between smart sessions. It just means the candies. It just means the candies.
Hey, Mom and Dad, dreams, dinosaurs, the whole uses your child's passions to craft a personalized learning plan. Your child will like it, and it really works. Almost proven to increase early reading scores by 74%. Pandora listeners get 2 cents off when you sign up today. Just tap the banner or go to learnwithhomer.com/Pandora.
Our job here is done.
Wait, chocolate because we're done. That's chocolate.
Access to all of the services. right from your computer. Buy hands-free automatic postage for anywhere, any package. No more expensive cartridge readers or time-consuming trips to the post office. It doesn't get any easier. And now you're listening to the special offer for stamps.com, including their innovative digital scale. Click on the
All right, guys, listen. 3, 2, 1. Listen. You have about 5 more minutes to get through this lab. Eat and finish through number 6. If you have questions with number 6, I'll answer them after my 5 minutes, okay? So chat with each other. You have 5 minutes to clean and eat. I was going that one, but you didn't take anything. It's not in the lab.
Why did you guys see all this? I looked on your website too. You see the homework. Yeah, I looked on your website. Yeah, I did. Well, it wasn't
Alright, last box in 2 minutes. Last box in 2 minutes. Oh wait,
Oh.
She already passed one out.
No, you said you grab them.
No, she already passed one out.
Oh, never mind.
Hey, who you calling stupid? That would be me. Excuse me, partner. We're still in partner.
I didn't get one cold.
Alright guys, all thumbs up, all button orders off. Let's go. Back to your desks with your papers in hand. Let's go. All thumbs up, button orders off. Down. Alright, in your back, butts and seats in 10. 9, bring your stuff with you if you don't have it, turn in the box yet. 8. 7. If it's done. 6, hold on. If it's not done, hold on, come back to your seat. That's what I said before we even got done. 5, 4, 3, butts in a seat. 2, butts in a seat.
Oh, yeah, turn it.
Yeah, I'm trying to get you guys to not dwindle. 1, okay. So, a lot of you guys did really well. I had one group I was going to get extra credit because they were very efficient and they were very on top of things and they didn't waste time. Some of you guys, I love that you enjoyed it. I just need you to stay on task with it too because I do want to make sure you're I'm answering any questions I need today. So, who's here? Where are we at? C. Okay, C. The rest of you guys all have a cross on your desk. Continue if you're done with this. Just I'm trying to make sure I've answered questions for those who still need it. So if you're on C, it says to take grams of chocolate to moles of marshmallows. How many steps is that going to take you? No. Grams of chocolate to grams of chocolate to what first?
Grams of chocolate to moles of chocolate.
Okay, so you have the chocolate molar mass right here, and then for moles of chocolate to
Moles of grams.
moles of, I did marshmallows first, and then a totally separate example, you'll take your grams of chocolate separately to moles of graham cracker. Okay, I'm leaving that up here for C. All right, for D, who figured out how to approach this in an easy fashion? Izzy.
So you do however many grams you have divided by whatever grams per mole it is.
Okay, so
like for chocolate, it would be 44.28 divided by 3.69.
okay.
And that gives you the amount of moles you have, and then you do that for all of them and see which one has the least amount of moles.
I won't say the least amount of moles because their ratios are different. Because you had 1 chocolate, 1 marshmallow, 2 graham crackers. So you're on the right track though. So everybody with me? On D, you got to get grams of chocolate to moles of chocolate, grams of chocolate, or grams of marshmallow to moles of marshmallow, and grams of graham cracker to moles of graham cracker. After you get to moles of each of those reactants, what do you then need to convert to? Anybody?
Mole ratio.
Say again?
The ratio.
So what do you mean, the ratio to go to what though? Doesn't it say it wants to know the limiting reagent? The limiting reagent, the definition of limiting reagent is makes the what? Least amount of, anybody? So if I have a limiting reagent, what does that do to my reaction? Stops it, right? So stops making what? Product, right? So I want you to figure out from here, chocolate, graham cracker, and marshmallow, which of those is going to stop making product? Well, you really can't do that just by looking at them. So when you convert to moles, you can then, no, Margaret, the other one. After you convert to moles of each of those, you can then convert to moles of s'mores. And whoever makes the least s'mores makes the least product, right? That means that they've stopped the reaction at that point. Okay? So take a minute and finish that if you need to. Otherwise, we're going to pause for a couple minutes while I'm going to give the folks to finish. Jasmine, did you finish?
Just leave it. Yes. Oh, thank you for that.
Well, I just watched this
Okay, should I go around?
I can run into it.
There we go.
Maybe I'll scare it.
Whatever the ratio is for marshmallow.
Okay, so I've calculated the amount of moles for each of them.
Wait,
I'm sorry. Okay, so that one's that's gonna be 8. Or no, why not? What?
Sit down, person next to you, put them for now, okay? There's two more rounds.
not as in like I'm thinking.
Oh, I have to.
Jacob, True, last couple comes on the table. My sister really clean now. Your sister comes on.
I got you. Oh, Jacob's already there.
He is on. Okay, so. One more, I'm gonna do mine.
I know it's not real. We just talked about like
No, I meant like
Okay.
actually,
Ready? So let's write stuff.
Yeah. GM.
Just for 2 moles of.
No, there's only. What's the 1-to-1 ratio? So it would just be 1-1, not 2-1. Graham crackers and chocolate, so it'd be 2. So basically, you just convert the grams to moles and then see what comes out.
When do we convert?
You just multiply across. And that gives you none.
Now what about?
No, I haven't gotten Graham crackers. I just got yeah, that's the same thing. Just get Graham crackers. So it's number 3 the same. Yeah, like what? 33 plus 1 mole equals 1 mole that, 1 mole this. All you do is change 2, 1 to 2. The ratio is the same. That's similar.
Try to do the
No.
Yeah, but I'm not using it for this. Right. Yeah, I'm using it.
When I'm thinking, can you tell me what that stuff?
I do have THEO. Okay.
Wait, help with the plus part? 1 more, and then 4 moles of graham crackers, and then 1
What's that?
I just can't
That's
tell
8 over 1. So you have to multiply everything by the ratio. It's just like 7.
What about that?
1 mole is 7.75. Yeah, just. Yeah, 1/2.
So it's 1/2. So it's
No, I. Why?
Yeah. It seems fractional, right? Slash seems fractional.
okay, so wait, what did you change?
I know, because I actually put. I actually put.
Okay, what's the ratio? 1 to
Literally all you do is convert that whole multiply by the ratio. So like it isn't like chocolate one time.
Alright guys, the s'mores lab should be in the box very soon. I do want to talk about PS 12. So I want to talk about PS 12 about 3 to 4 minutes.
In the definition it says atom.
I don't think the definition covers.
Yeah.
What's
You'll know more.
In your hair.
And my hair.
formula for potassium chloride? On now. You know how many times I've got potassium? Or sodium.
Okay, crossword. Here we go.
Alright, I was taking a quick survey. Who's already done number 9 on problem set 12? Who's already done number 9? Alright, a couple of you guys keep working. I'm going to approach number 9 right now. So if you need some help with number 9, I'm starting from the bottom, then we're coming here. Okay?
Zoe spent like 30 minutes on FaceTime on that.
Oh my goodness. Well, then you guys keep working. Okay. Alright, so if you are working on number 9 with me, I'm not literally doing it for you. You're going to walk me through it, okay? So help me out here. Whenever you look at number 9, it says consider the synthesis of aluminum oxide. Okay, so you are writing down the reaction first. Go, write down the reaction first.
Is number 21 angry? That was my first. That was the first one. That was the first one. That's just joking.
No, it's not.
One thousand of 3 across. Yeah, no, thank you, but I wasn't doing it.
All right, if you are working on your crossword, keep it to yourself. Because I can't talk over you, okay? Olivia, get me started on synthesis of aluminum iodide. Give me one of the reactions. Aluminum, she says questionably. Anthony, give me the other one.
Iodine?
How do I write iodide?
3?
5,
1.
No. One of those, right? Make a choice. Because it's a diatomic molecule, right? Okay. Everybody, what's aluminum iodide? Whoever's with me here.
ALI3.
ALI3, because you crisscross charges. Remember that, okay? Zane, balance this for me. Zane, can you balance this for me? A 3 here and a 2 here. So you said, okay. All right, so determine the limiting reactant if 13.5 grams of aluminum reacts with 0.72 moles of iodine. I know this is limiting reactant problem 1. It is a dead giveaway. And then 2, because it gave me aluminum separately from moles of iodine. So I have to figure out which of those matters in the grand scheme of things. So, Evan, get me started. What do I do with the 13.5 grams?
13.5 grams of aluminum.
Yep.
And then we know that roughly 27 grams of aluminum equals 1 mole of aluminum.
So what am I converting to?
We're converting to moles.
Okay, so we're taking grams to moles, right? Always first step is go to moles. So 26.98
Yeah.
grams of aluminum, 1 mole of aluminum. Ready when you are. Somebody's going to calculate this for me? 0.500 moles of aluminum. Okay, and what do I write here to indicate that I have this much? Have, right? I need to write have here. I'm going to forget how much I have. Okay? And then, who's with me here?
Me.
Jasmine, go and dig up. What do I do? Oh, look! I already have moles. Score! So 0.72 moles of iodine. I write here, what do I write? Have. This is how much I have of aluminum. I mean, iodine. Okay. Okay, everybody, I got some moles. Step 1 done. What's the next step?
Figure out your needs.
Figure out my needs, and I'm going to write a little X here to say am I multiplying by what? What's the ratio, guys?
2 to 3.
So it's the two that are both reactants, so it's got to be 2 and 3. I just got to figure out how to stack them. What goes on the bottom for the aluminum one?
2.
2, because the 2 for aluminum has to cancel out with the moles here. So this is 2 moles of aluminum. On top is what? 3 moles of iodine. Sorry, I'm getting kind of small here. Okay, and down here, what happens to the ratio? It's flipped because it's 2 to 3. It's going to be the opposite comparison. So that is 3 moles of iodine for every 2 moles of aluminum. Okay? And this is going to be how much I need of iodine. So that should be, yeah, thank you. I was like working on this. 0.75 moles of iodine is how much I need. And then I need, what is this? 0.48 moles of aluminum. That's how much I need. Okay, so I have made it to the crossing point where I have to figure out what the limiting reagent is. Very first step, and just as a reminder, you have to get some moles first. And then you use the ratio to compare. And then you have to do like have need comparisons. So Will, who's limiting here? Who's limiting here? You with me? Okay, you're doing your crossword. Evan?
So limiting reagent is iodine is have 0.72 moles, but you need 0.75.
So you need more than what you have, right? So what is going to happen to this? What's going to happen? I'm comparing moles of iodine, 0.72, what I have, to 0.75. Do I have excess or am I going to run out? I'm going to run out, so I need more than I have. Like I need 10 cookies, but I only have 5. I'm going to run out. And then the aluminum, I'm going to have what? Excess.
Miss Eno,
Yes.
could we get Emma for this missile?
Thank you.
Thank you.
Bye. Just leave the homework, okay? All right, so now that we know our limiting reagent, the whole point of this entire process, some of you guys are paying attention, some of you guys are not, work with me. The entire process, what's the point of it? Somebody else tell me. So what? No, the whole point to like do this before I start solving the problems.
So that you can use the have and the need here.
Okay, so I can use the have and the need in my the problem-solving process. Also, I must use the have to start the problem-solving process. So, yeah, I have to have a given. I can't have two of them. I can't really work with 2 things. I got to work with 1 thing. So, which of these things matters?
The have.
The have of which one? Iodine, right? This is my starting point right here. So, 0.72 moles.
So whatever the have needed.
The have of the LR. Is that what you're saying?
Okay.
Yeah, whatever the have the LR is my given is my starting point. Okay, so what are we solving for in B?
Wait, what about A?
I think I got it. Determine limiting reagent. Done.
Oh.
LR, or the LR is iodine. What am I solving for in B, guys, if you're with me?
Do a maximum amount.
So give me that in like stupid terms.
ALI3.
So, but what am I looking for? What unit? What's it mean by maximum amount? Probably what unit? Grams, right? The question is grams of ALI3, and that's what my final step is going to get me to. So grams of ALI3. So what's the next step, everybody here? I can't work with iodine anymore. So say again? BC mole ratio. So iodine is 3, aluminum iodide is a 2. So who goes on the bottom here? 3 moles of aluminum or of iodine. And who goes on top? 2 moles of aluminum iodide, which is from the 2-to-3 ratio here. And that's only because my question was grams of aluminum iodide, so I had to eventually get to just aluminum iodide. And then somebody tell me what the next step is. Use the periodic table, get the molar mass, which I'm converting the whole time, right? So for every 1 mole of aluminum iodide, what's 120? Somebody got a calculator? Let's go, Luke. 126.9 times 3 plus 26.98. Thanks. And then you guys can calculate this to be your grams of aluminum iodide. Any takers? Okay, I'll let you guys calculate that. Yeah. Somebody else may have. I don't believe in it being that. Okay, I know. Okay, guys, listen. If some of us are kind of checked out on me, but listen for me. Have a happy Tuesday. 6, 7, 8, 9. Okay, so I gave you the weekend. I gave you some time, but I do want you. I'm not asking for more problems at 12. Okay, I've assigned 1 through 3, and then separately I assigned 6 through 9. If you have more, great. That's extra practice. You have plenty to practice with. Expect that your crossword and your problem set, what I've assigned to you, is due Wednesday. Okay, crossword's pretty easy, but it's good for vocabulary practice. Other than that, s'mores labs in the box, right? S'mores labs in the box. Awesome. We leave in like a minute. Thanks, guys, for bringing stuff in. Appreciate it. Oh my goodness. Did we cut your hair out? What happened?
No, okay, so I like shoved it under the sink and I just pulled really hard.
It's just sugar. It's not like
Yeah, I just
stains.
feel
It's not
how
like it's
sticky
gum.
it is. Like, it's actually crazy. I was like, how is this even real?
Marshmallows every time.
I love myself.
Guys, if you take my labs off the tables, go put them back.
Unless you want to.
I'll probably not.